I'm Liam. I'm going to talk about LVGL's repo for the new STM32H7 board. This is a new H7 series MCU from ST that's in their very high performance series. It has a 600 megahertz Cortex M7 CPU. It's a development kit with a screen. It's 800 by 480. This MCU has a NeoChrom GPU. It's important to note that this one does not have vector graphics, but it's still able to accelerate all the other drawing operations and make full use of LVGL support for NeoChrom drawing. As with distinguishing any MCUs, there's always something to be said about the memory architecture, and this one has quite a lot going on. This one does have data and instruction caches, and there's what's called tightly coupled memory, which can be used for things that are accessed very frequently. In this project, the stack is in the tightly coupled memory. There's external RAM and internal RAM, and as you'll see, different regions of memory are configured to have caching enabled or disabled for special reasons. So yeah, just going through some more of the overview here. It has quite a large external flash and quite a large external RAM. That's one of the things to consider with this MCU is that it has a very small internal flash, and there's not much that you can do in an application without the external flash. So a bootloader is required to jump to code that's in the external flash, and some extra building steps are required to flash that external flash. You can see it performs quite well across all of the benchmark scenes. The display is 24-bit, currently configured to 16 for performance. So here's the cloned repo. The directory structure of the project is a little bit different than what you might be used to. There are links between the different directories in Cube, so the way it looks here is a bit different than how it looks in the tree here in Cube. You can find main here. The LVGL submodule is under STM32CubeIDE and then apply LVGL. And the conf defaults and conf.h are here. So this is as I said, this is the application, and here's the bootloader. If you are using the project for the first time, you will want to flash the bootloader before doing anything else, and then you won't need to do that again. So what you do is you make sure that this is highlighted, and then you click launch to build and flash the bootloader. So that's it. It built that and flashed it, and now you can close it so that this project is the only active one, and you can build and flash the main application. After the project has been flashed, it's important to note that you need to push the reset button on the board or remove power and restore power. So the reset button is this black button here. You just push that and it will reset the board. Until you do that, it will just be a black screen. I'm just going to briefly touch on how the memory management unit is configured. So this is basically just to make sure that the memory that is shared between the CPU and the GPU is not using the CPU's data cache, because whenever the CPU wants to write something that the GPU can see, it doesn't want it to get stuck in the cache before getting written back to memory. So these two configurations right here, the high end of the internal RAM, this 16 kilobytes plus 8 kilobytes is configured as not cacheable, and that also has support from the linker script. So RAM command is the special memory definition that starts at the end of RAM, and it has this section named GFX memory pool buffer, and it gets its own special section. This array gets its own special section that has this attribute, and that attribute is here. It's defined as the corresponding linker section. So this array, memory accesses to it will not be cached in the CPU's data cache, and it is used for, as I said, the memory pool that is shared with the GPU. It's using the Cortex M7 version of the NeoChrom library. In LVGL, there are static libraries for NeoChrom for the different types of cores, M7, M33, M55. So the project is configured to link against that version of the library. You can see here that this is the path to the search path for extra libraries to link, and it's linking this. It wants to link this library. If you want to make a change to LVConf, you can make the changes in this defaults file. So if I were to enable this assertion, can save the file, and then just outside of LVGL is where lvconf.defaults and lvconf.hr, and you can run the script inside of the scripts directory. And lvconf.h will be updated. Earlier I was talking about the memory protection unit configuration. Typically you wouldn't edit this main file. You should open this IOC file. In the next version of CubeIDE, they're going to remove this embedded CubeMX view, so that's something to watch out for. But as of 1.19, you can still open the IOC file inside of CubeIDE. Okay, so here it is. You can see that you can change the memory protection unit settings in here. So this is where you should change it, and then regenerate the project with this button right here. Anything that's in like main.c is something that should be configured in here and then regenerated to update those that initialization code.